Hello, my name's Claire and I'm an application specialist at PerkinElmer. In this tutorial I will demonstrate how to automatically measure distances between objects using velocity quantitation. We will make use of the concept of populations and defining relationships between populations. You may wish to look at the relevant tutorials before proceeding. As an example, we will use a dataset which shows signals from two back DNA probes, labelled with Texas Red and FITSI, in embryonic mouse tissue. The whole nucleus is also shown in the DAPI channel. One of the backs maps to a gene of interest and the other maps a short distance away. In areas of tissue where the gene of interest is transcribed, the chromatin is reorganised, which results in an increase in the distance between the two probes. This distance is therefore used as an indicator of expression of the gene of interest. Here we will create a measurement protocol to measure, in 3D, the distance between these probes. Click once on the data in the library and click on the Measurements tab. We first need to identify the different objects and group them into populations. Here, populations of green back probe, red back probe and the whole nucleus have been found. To learn more about how these populations were identified, please see the tutorial on working with populations. We will first look at how the Measure Distances task can be used to measure the distance between two populations globally. The Measure Distances task allows you to automatically measure the distance between the members of a population and all of the members of a second population. Add the Measure Distances task by either double-clicking the task or dragging it into the Measurements protocol. Select the population from which you wish to measure and the population to which you wish to measure. In this case, measurements will be made from each member of the green back DNA probe population to each member of the red back DNA probe population. You can base each distance measurement to or from the centroid of each member of the population, or the edge of each member of the population. To make this choice, click on the cog of the Measure Distances task and make the choice in the dialog that opens. If the edge option is selected, the distance to the nearest edge is always measured. After configuring the Measure Distances task, all of the distances between every member of the first population to every member of the second population will be measured. In this case, the distance from every red back probe to every green back probe is measured. These distances are summarised in the measurements table under the column headings shown. In an alternative approach, we may wish to restrict distance measurements to compartments. To do this, a compartmentalised task must be added to the protocol, and it must precede the Measure Distances task. Distance measurements made in combination with a compartmentalised task are organised on a per compartment basis. Distances are only measured between members of different populations within the same compartment. In this example, we are interested in distances between green back probes and red back probes that are inside the same nucleus. We therefore need to nominate the nuclei as compartments and divide the green and red back DNA probe signals between the nuclei. To learn more about how these compartments were assigned, please see the tutorial on defining relationships between populations. Add the Measure Distances task to the Measurements protocol. Select the populations from which you wish to measure and the population to which you wish to measure. In this case, measurements will be made from each member of the green back DNA probe population to each member of the red back DNA probe population. Configure the Measure Distances task as necessary. All of the distance entries within the measurements table are now organised on a per compartment basis. A summary of these measurements can be made on a per compartment basis. In the example shown here, the mean distance from red back probes to green back probes can be summarised per nucleus. From the Measurements menu, select Make Measurements item. Choose the option to make a new measurement item and enter a name for it. A measurements item is added to the library. Click on the measurement item to open the raw view. This contains identical populations, each represented by a page, to measurements displayed in the measurements view. Click to view the Analysis tab and from the Analysis menu select Analyze. In the Edit Analysis dialog box, select the option to analyse the max distance from red back probe to green back probe. The data is summarised by mean and organised by compartment DNA ID. The mean maximum distance from the red back probe to the green back probe is now displayed as a mean value per nucleus. From here, we may wish to export some of this information into a format which can be viewed in other software packages. In the File menu, choose Export and the required format. Thank you for joining me for this Volocity tutorial. If you would like any more information about Volocity, please contact one of our imaging specialists.